All right, welcome everyone. This is the first edition of what we're calling the BDK Tech Talks. So, the Bitcoin Development Kit Foundation is we're trying out a new thing where we're going to get developers on the team and users of the BDK libraries to come in and speak about all sorts of different BDK related things as part of the ecosystem. So either users of the library in production that want to tell us how they use it and show us what they do with it, or devs on the team that want to tell us about a particular piece of software they're familiar with, or maybe a new feature that's coming into a future release, something like that. So I'm Thunder Biscuit. I'm in charge mostly of the language bindings for BDK. So I maintain the core repository for this is called BDK FFI. And I was a Spiral grantee for a few years until I went and became a grantee of the BDK Foundation. So that's what I do full time now. And I'll be telling you about why BDK does bindings and which languages we do, how we do it, and all of that. Lessons learned and how to use them. So it's April 2025 right now. The 1.2 version of BDK, the Rust BDK wallet library, just came out yesterday. So we're proud of that. It's awesome. For the bindings, though, for this presentation, it's a 1.1 version that I'll be showcasing in this case. So let's get going. This presentation, I'm hoping, is going to be, less than an hour, and we'll be going over a whole lot of stuff. Again, first of the BDK Technical Talk Series. So some of the things I want to talk about and touch on is how does BDK produce language bindings for its Rust library. So BDK, you might think of it as like a single library, but it's actually a family of libraries. So there are a few clients: Explorer, Electrum, a compact block filter client called Kyoto. There's an RPC client, and then a series of crates that basically come together to make this higher level library called BDK Wallet work seamlessly, but also allow you to go down and get into the nitty gritty if you need to. If the BDK Wallet is not quite doing what you need, or your use case is really specialized, you can use the inner parts, the inner libraries, basically to get at what you need. We'll be discussing trade-offs, like what does it mean to build language bindings, and what do you give up when you do that, and what do you gain? Of course, there's a lot of gains, and that's why we do it. But there are trade-offs to be aware of, like things that are, not as easy, or pitfalls to basically make sure you know about before you get going. Or if you're interested in building libraries, building language bindings for yourself or for your project, this is some of the stuff I'll be discussing here. And then we'll take a look at a bunch of code. So I have we'll go through some of the Rust code base that is part of that. So to create the language bindings, we're not actually just pulling directly from BDK, the BDK libraries. There's sort of like a wrapper library that takes some of the types and some of the API from the BDK wallet and some of the other clients and sort of wraps them all into this one library that people can then export at the language, the layer. For example, in Kotlin, in Swift, or in Python, they can have a single import and they get all of that wrapped up into one. And then we'll build the libraries live. So I'll do this right with you guys. It's not hard, I promise. And then I have a few discussions on other related projects that we want to, build on, and then some of our sample applications for these things. So let's get to it. Why do we build language bindings? So that's a good question we should ask. And I think the core idea behind this was that for a while now, the Rust language has been where a lot of the cutting edge of Bitcoin is being developed. So a ton of the new features that are in BIPs, but that doesn't mean they might be a BIP, but that doesn't mean they are implemented in code. And Rust is one of the places where usually those get implemented first. So when leveraging Rust for Bitcoin, you get a lot of the latest, the cutting edge, and more than that, you also get a lot of the review, like the heavy review is is very in Rust. That's where you get it the most often, and this is not, nothing against other languages, but it's just that this has been for a few years now one of the things, one of the features of this Rust ecosystem for Bitcoin. So when you're thinking about things like Taproot, things like Miniscript, output descriptors, PSBTs, those are all really advanced, well-reviewed, developed in Rust, and less so maybe say in Ruby, right? The sort of like the depth of that developer pool in Bitcoin is less there for some of the smaller languages, and is really heavy on the Rust side. And so we want to leverage that and pull that into other languages that people want to use for, particularly for, in our case, mobile users. So that's Swift and Kotlin for Android, Swift for iOS. But we also do it for Python, and there are other languages even on top of that. So there's third-party maintained libraries as well for other languages that you get for free when you do those. A bit of history on on BDK and the language binding. So BDK initially started as a project. It was actually two different projects. The first one was Magical Bitcoin, started by Alikos Fellini. He worked at Blockstream at the time, and started Magical Bitcoin as a sort of a side project, and that rapidly became sort of interesting, and more devs joined and started, talking about how that might work well, and the value of having a higher level logic and library for building wallets than was currently available in Rust. So at the time, in Rust, you had Rust Bitcoin, which is another series of crates, but they're very low level. Rust Bitcoin is mostly just like types. So and Rust Miniscript, but then there wasn't anything combining all of that into a single well-defined and easy to use API for wallet developers who just wanted to, build wallets and get balances and, connect with the Electrum servers and stuff like that. So this was started on one end, and then on another end, another developer, Steve Myers, got a grant from Spiral to work on a library like this, and it was called BDK. And one of the core goals from the get-go was to provide language bindings for mobile users. So Rust was a perfect language for that. And eventually, after a few months, those projects sort of like found each other and combined into one. And they actually kept the BDK name. So Magical Bitcoin was the Magical Bitcoin code base, and BDK name. That's how it ended up shaking out. And so we've been building language bindings ever since. It was initially much simpler and less complex and less simple than it currently is, actually, I should say. But yeah, that's how we ended up where we are. My next item I want to talk about is it hard to build language bindings? Yeah, that's right. That's a good question we should ask. And I think, honestly, the answer is no. It's not too bad. We use a tool in BDK. We use a tool developed by Mozilla. They use it for the Firefox browser on Android and Swift. So it's a tool that produces from Rust language bindings to three core languages: Kotlin, which is Android; Swift for iOS; and Python. They use it for their test suite. So you get those three languages as part of this, and we'll dig into the code base a little bit later. I'll show you how basically the sausage is made there at that point, but you add attributes to your Rust code base, to your types and some of your constructors and methods, and those get sort of automatically exported into these other languages. So that's the tool we use. That's been all right. It's honestly a fantastic tool. It's very much in development, so there's always breaking changes. You need to be really on top of it. But other than that, I would say that it is fairly easy just to produce the language bindings. So if you're using them, we have projects that have decided to actually produce language bindings using Unify, and just produce their own language bindings for their project. So you might have like a few things that you write in Rust and you export that into libraries that your mobile application can then leverage directly. So there's no actually publishing of those libraries to places like Maven Central or PyPy. The objective is not to publish those libraries, is to literally use them. And so in the project. So if you do that, you can actually have those directly in your code base for your project. Not a bad idea, but it is, requiring a whole build system, and you need to understand how it works, of course, to get there. So that's one thing. I would say for us, some of the places that have been the hardest is, of course, that you end up maintaining, publishing, and learning about build systems for all of these languages that you want to maintain. So that's, again, that's for us 3 languages, and including the publications, which always is something new, something you need to learn. So publication to Maven Central for Kotlin and Java, and then PyPy, and then Swift is using sort of a publication where you use like a specific GitHub repository. It's like a special side GitHub repository to publish your libraries there. So all of that requires like CI build scripts, and it's a lot of learning in that sense. So that part has been more difficult in a way, but you learn it, and then it's not it's not rocket science. Over time, you develop the workflows that make it work for you. It's still a fairly manual process in that sense, because every language is different. So there's a lot of learning there, but otherwise it's not too bad. And lastly, I want to talk about trade-offs. So the language bindings, particularly not just creating language bindings, but like at the Rust / Unify layer, when you decide to build language bindings using Unify, there's a few things that are, trade-offs that you want to understand and that you need to basically juggle. And some of those are, for example, that a few things don't translate directly. So you can't, of course, there's all those languages have different features and different, like that last little layer that makes a language very smooth and magical for whatever that language developer is used to. So and what makes Rust special, for example, doesn't translate into Python, and what makes Kotlin special doesn't really exist in Rust, and it's the same for Swift. So you end up to create language bindings for all of these together, you end up sort of like pulling into a lowest common denominator, things that everybody has. So things like enums and like objects, constructors. So a lot of the core basics, those all work. But some of the things that make languages special then don't work. So there's a few things you can't use. And that means that it is difficult to just grab a code base, like a Rust code base pure, that is written for Rust, for the purpose of Rust users, and simply say, I want to use Unify to produce language bindings for that. It doesn't work that way in general, because that code base will have a bunch of things that make Rust special and are useful for Rust devs, but that are not accessible in Swift, say. So for example, a super simple example of that is tuples. Rust functions can return tuples. That is not a thing in Python. So there you go. You have to return something else than a tuple, and that will require a little wrapper. So you probably return a specific type that has 2 fields on it, say, and that's one thing you got to do. Another thing that is not available in Unify are generics. So depending on your code base, and the BDK code base has a lot of generics, then nothing can be, you cannot provide that using Unify. So you can't expose that, I should say, using Unify. And so your wrapper library needs to flatten all those generics. So you need to basically have concrete types for all of those, and that creates like code that's a bit like not as you'd say, like best practices are beautiful sometimes as the way you'd have it in Rust, in pure Rust. So you need to be aware of that. In general, it's not a big problem, but it is something you need to be aware of. Some of the other trade-offs probably include things like library sizes, where specific languages would produce, depending the situation, we probably produce libraries that are a bit smaller. For us, it hasn't been a problem because in general it's fairly small. So the library is still like under 10 megabytes. So it's like 6, or depending on your language, I think in Python it's 4. And so the libraries are not too big. And for mobile users is particularly where we're concerned about that. We want to make sure we don't, give you libraries that are, 200 megabytes in size. But they haven't been too big, but it is something to know. And so, yeah, that's one thing. Another thing to note is that in general, the way Unify works is you need to package all of your functionality into a single library, a single import, because you produce the binaries from the Rust crate, and then there's a glue code file in the language you are using, so Python or Swift, and that glue code file is what the users at the Python level, for example, see and use, and then it calls into the binary library. That's roughly how it works. And this makes it so that you cannot have compatibility between libraries. You couldn't have, for example, as an Android dev, import 4 libraries, BDK Wallet, BDK Electrum, and BDK Explora, and all of those have types that are compatible between each other. As opposed to if you were writing them in native languages, you would get that for free, right? Like Rust users would have access to types that are compatible between the libraries, but in this case, you can't reuse the amount type from a Bitcoin FFI library into a BDK FFI library if they are separate imports at the Swift layer or at the Python or Kotlin layer. And that means that you need to bundle everything you're going to need, or that your users are going to need. For example, for us, it's a whole, for us, I think it's nine or 10 libraries that we actually bundle all together. That for a Rust dev wouldn't be as many imports, would be many imports in your cargo file. But for an Android user, it'll be a single import and it'll have everything they need. That makes it so it's a little thicker than you would probably use if you were just like a separate user. You would on Android, for example, you would use BDK Wallet, and then you'd import one of the clients which you want your users to have. In our case, they need to import the one library, and they get all the clients all bundled into one. So that's one of the things that happen. But we are working on different options for that. There's ways to probably mitigate this over time, and we are certainly working on exploring that. All right, that's roughly what I had for the overarching big ideas type thing. And now I just want to dig into the code base. I want to show you guys how it looks, how the sausage is made, and yeah. So let's look into let's look into the code base directly. So this is BDK FFI, the core sort of code base, which holds all the libraries, the core libraries we maintain: BDK Android, BDK JVM, and BDK Python, and BDK Swift. So that's 4 libraries. And in fact, from BDK JVM, you get Kotlin, but you also get Java for free. So that's another language we get sort of for free because Kotlin and Java are compatible that way, both running on the JVM. I will open up our Rust code base. So this is if you get into BDK FFI. This part is just straight Rust. Yeah. So cargo, source file, all of that. This is my Rust rover, and I'm gonna just take a look at a few types for you, and we're gonna sort of take a look at this. So well, first of all, my cargo file has a bunch of imports, and in this case, it's BDK Wallet, BDK Core, Explorer, Electrum, Kyoto, so which are the three clients we're exposing right now in the bindings. And BDK Wallet then, re-exports Rust, Bitcoin, and Rust Mini Script. The idea here is that we're going to take what is needed at the Rust layer, what we want to expose, and add attributes to those. So for example, I'll take the fee rate here, the fee rate type gets a special attribute. Unify requires this Unify object attribute on my struct. And then I export it using line 64 here. This attribute will export the fee rate object. And then I just add my constructors. It's another attribute on the constructors. In this case, they are like named constructors, so they're not the standard sort of new Rust constructor, which would produce the default constructor on all those languages, Swift and Kotlin and Python, which are the name of the type, parentheses, and then your arguments. These will be the named constructor. I might have a standard constructor somewhere else. Yeah, so script would be an example with a standard constructor, a default constructor, I should say, and that will just output. It will not be named new for the languages. It'll just be named whatever the name of the type is. And that's it. So if you can see there's a 2SAT method and 2BTC method on those, and they will get exported for free here at this point because of this Unify export on line 103 on the amount. Another sweet thing we get from Unify is it picks up on API documentation right out of the gate. So in this case, we pick them from the Rust libraries and we just pull them here, and they all will get pulled into the API documentation for the languages. So people using IDEs in those languages will get API docs as if in their natural languages, languages that they're using for development. This was not always the case. This is a new feature of Unify as of a few months ago, so we're happy to have that. And the code base is fairly simple. I mean, it's the way we have it set up is we use a single file to denote mostly the modules in BDK Wallet. So there's a descriptor module, and then those are, for example, the client, the Electrum client is not a module of BDK Wallet. It's a separate library, but we expose it here as it's in its own file, and then Explorer, Kyoto, and then we have the transaction builder and the wallet, which contains the biggest part of the logic that we want to expose for BDK users. When I go to my command line here, hopefully the font size is good enough for you guys. From BDK FFI, I can just build it. We have put a lot of effort into creating cool and really useful just files. So if you're using the just tool, this is really the way to do it, where this one is maybe not formatted super well, but I'm just going to build it, for example. So I can do just build, or if you're familiar with Rust, in this case, it'd be cargo build. So this is building just the Rust part of this whole thing. So at this point, I haven't built any language or language binding libraries at this point. We're just like compiled basically the Rust code base. Everything worked. You can, format, check, that sort of stuff. And that's it. There's nothing too crazy about that. The core of the idea is at this layer where you get the Unify lines, exports, constructors, objects. There's enum, there's a few of them. There's also traits. So you can also export Rust traits, which then become interfaces that have to be implemented in the languages. And that's it. Easy. We're gonna take an example here. I'm gonna build the JVM library for you guys. So we'll pull my IntelliJ. And if you're familiar with Kotlin or Java here, I have my main, and we'll delete this old file. So my library at this point has no source code in it, right? It's completely empty. There's just a packet, in this case package, but I can even delete that. So there's no source file at all, no package, no nothing. And we will build it. So, sorry, BDK JVM. From there, again, I have this one is better formatted. I have a list of things I can do here at this layer, and we're just gonna build it here for my architecture in this case. And you'll see how this is done. If I look at the just file, when we build, when we call the just build command, what it's going to do is actually run the script associated with your system directly. So, sorry, not plugin, but in my scripts, I have, in this case, we're going to run this script. So I want to take a look at this. This is where it gets interesting. We add our, the default Rust version we want to use for the build, compilation targets, and then we build a Rust library just like I did before. This produces a library. In this case, it'll be a dylib library, and from there, line 17 here is where Unify comes into play, where we're going to use a CLI tool that they produce for us and build the glue code for that binary. So it'll go and scan that library and then produce one file. It'll be called bdk.kt in this case because it's Kotlin, and it'll produce this glue file, and that's what users will be able to interact with. And this is the file that, or the code that basically calls into the binary. And then we pull in this file, and we put both the glue code file into my lib here, into my main, right? And the binary into the resources, so that here, this is an old version of it, but so that the library can basically pull on it as just like a standard resource. Let's do that. So I can do just build. And this shouldn't take too long because I've already compiled it before this video. Maybe not. There you go. The result of this is twofold. My resources here have now a new libbdk FFI dylib library. I should have removed it before to showcase that it's now appeared, and my Kotlin, my source code now has this package, org bitcoin dev kit, and this bdk.kt file. And this is a huge file, like we're looking at 12,000 lines. But it has all the everything that's in it. For example, here I'm looking at the wallet, and you can see that we have all the methods on the wallet. So apply, update, balance, calculate fee, and those they come with their API docs. So that's it. People will then be able to import the library, and then they import those types, and they can use those types in the methods, which then here ends up there's a whole lot of code to basically call into the Unify library, the binary produced that's in the resources. So we'll take a look at tests here. So for example, a live wallet test. This is in Kotlin, and we can see that it just looks and behaves just like any other Kotlin code. You don't even know that really it's a language bindings library or anything. So that's interesting. The import, I don't have the imports here because it's part of it, but yeah, those types get imported just like any other type, and we get API documentation on them. So if I do Explorer client here and I hover over it, I get my API docs. Yes, the Kotlin library sort of auto-generated itself. But I mean, I built it basically with the just build command here, and what it produced, this command basically will produce two things: the resource file, the dylib library, and the bdk.kt library, and those speak to each other. I mean, rather, the Kotlin code that's generated, this is generated by Unify. So this is auto-generated. There's no, it's not a manual process. And it's a new one that gets generated every time you rebuild, basically. So if you make any changes, it'll just, regenerate itself. And then it expects to find a binary in the correct location. So that's another thing. You need to have it in the correct location, fully compatible. But this process, again, is like, done in the CI for us, automated. It took a while to figure some of the kinks out initially, but now it's easy and it always works. So that's it for this. Yeah, we took a look at the glue code. Let's take another look just for fun. We'll look for something like that's super simple. So the network. This is an example, line 18,000, and it's got all my networks right here. This one is particularly simple, so they're not all of them are that simple, but yeah, this one is one of those really simple ones. It looks very similar to how you would have written it if you wrote this class in Kotlin directly, probably. Next up, well, now they're all fairly similar, but I'll actually I'll show you one more thing we can do here. With my tests, we have the just file is like neat and sort of well done here. So if I pick the live wallet test, for example, you can do just test live wallet test, and this should run it. You can test all of the tests at once, of course, or you can test a single instance, a single class. I'll let this guy go. Yep. Here you go. All tests pass. That's it. That's what it is. For Swift, it's very similar for Swift. I will take a look at it in this case on VS Code. But my the build script is only one in this case script. So build XC framework .sh, and it's you can take a look. It has roughly the same ideas behind it. There's a little bit more because it's building for 5 different architectures, but yeah, it's very similar. You build the Rust library, and then you build the glue code. You combine those so that the glue code has access to the binary, and that's it. For Swift, you sort of like combine it into this framework from the get-go, so it builds the library directly. And so I'm just gonna do just build. It takes a bit longer to build because we're always building, in this case, for all 6 targets. For JVM, I have it set up so that if you're just building locally, it only builds for one. But when we do it in the CI for releases, it obviously builds for all architectures. So that takes longer than it does locally here. But for Swift, right now, it builds all architectures all the time. So it can be a bit longer. But the resulting file will be this. This is the glue code. Let's take a look at amount, say. Don't know if that's gonna work. Might be far. No protocol. There you go. So amount has 2 methods, 2 BTC and 2 SAT. And yeah, in this case, it's it's written as a public protocol, and then you have the open class for it, which will have the constructor on it. It's a lot of code that's, you need to sort of get familiar with it if you really want to dig into it, but mostly it's not required to understand all the inner pieces of the glue code. But yeah. And then we have our tests, and the tests are 1 for 1 in this case. The JVM test and the Swift tests are all the same. So, but I certainly encourage people, if you're interested in our language bindings and you want to use them, a good way to understand the API in those languages is to take a look at our tests, which use the API quite extensively. Another way to do this, if you're interested, is to look at the Rust code. The API docs for Rust are super good. If you're not familiar with them, it's difficult to parse at first. I find Rust docs took me a bit of time to get used to, but now once you're used to them, they're quite useful. And for BDK, they're really well written and they're very complete. We put a lot of care in having good API docs, so you're able to find all the methods, things. If something's available in the bindings, you can usually find an equivalent, of course, in the Rust layer, and that will have all the API docs associated with it as well, and sort of related things. Some of the difficulty there can arise when you have APIs that are available in Rust but are not exposed in the bindings. So not everything is 1 for 1, right? We don't have access to everything that's in Rust in the language bindings as we speak. So we're always exposing more and more of it, but it's not the entirety of the Rust BDK ecosystem basically that's exposed in the language binding. So you might find methods that are in Rust but are not in the bindings. or sometimes they've been reworked into something that can work in the bindings, but is not exactly one for one in Rust. One of the decisions we've made early on for the bindings is to not actually rewrite a lot of the logic for the Rust libraries. So we're not trying to do wrappers on the logic or combine methods or things like that. We are attempting to expose the Rust libraries one for one. So even in cases where, the naming is a bit weird, or we like, I might not like a specific, parameter name, but we don't actually do that sort of decision. It's really, that's happening at the Rust layer. And so for the bindings, we just re-expose as is the most we can. So, and there are even with Unify, there are even situations where you can expose types directly. So there's no need to wrap at all. And then when that's possible, we do it directly. Sometimes it's not possible. There are, fields that have generics, or things that, types that have generics in them. So then we need to do some wrapping, and that's why the Rust code base exists. Basically, the BDK FFI, the Rust part of it exists because there's sort of a minimal amount of wrapping we need to do on some of our types. But you will find, if you dig into it, that the code base is very, very light on logic for Bitcoin. Basically, we're not attempting to rewrite or rethink any of the BDK logic. It is simply doing the wrapping to provide available APIs for the bindings users. So sometimes people ask for features at the language binding layer, and we always point them up to the Rust layer. So if there's something that's not available in BDK, you want it in the bindings, you're going to need to have it in Rust first before you get it in the bindings. I'm getting errors here. I'll have to take a look at that. I don't know exactly why this happened, but I do have an old version of the glue code, so we could take a look at it. So I'm happy about that. And the last thing I want to do for this is take a look at the Python one. And I won't build it because it's very, very similar, but for Python, again, you produce using these scripts. We produce the binaries, and then we produce the glue code. And I'll show you some of the glue code. Again, we'll take a look at the amount type just for fun. Script amount. Amount. Yeah. So this class amount will have you can see the methods here. Actually, so those are the two constructors, the from BTC and from sat, sorry. And they're in Python, so those are, declared as class methods. So they're constructors. It's basically like a static method in Java. And then the toSat and the toBTC, which are methods on the type. Come out like this. Easy peasy. I want to show you some of the way this looks once we produce websites that are producing the API docs. For example, this is the Rust equivalent in BDK Wallet. If you look for the wallet type, you will find the API documentation for it, all the methods, examples, that sort of thing, method signatures. And if you look in for JVM, you will find a similar setup. So we'll look for a wallet, and this will have this my constructor. There's a bit of extra noise here because of Unify, which is, exposing those. The docs are auto-generated, unfortunately. So some of those are like public. They must be public, but they are then, they're not, how should I say, the API docs basically just pull them automatically. So that's too bad. But in general, it works really well. You can see I have all the documentation on all the methods here. And so that's really useful. You get those in right now Swift in your IDE, BDK JVM for Java as well, if you're using it in Java or Android and Kotlin. And we have a PR open for doing that in Python as well to produce the website, the API docs website in Python. So hopefully that's coming soon. And the Python library, there you go. And that's actually my last slide. But there's one more thing I want to talk about before we wrap up. There's another library we maintain. So hopefully that was interesting to everyone. Seeing how this is how we build the bindings, why we build them, and how easy or hard it is to do that for yourself. There's another library we maintain I want to talk about now that we're going into maybe the appendix of this presentation, I should say. Is a library called Bitcoin FFI. So the idea behind Bitcoin FFI would be to produce a language bindings library for common types that not only BDK uses, but other users of language bindings, like other libraries in the Rust ecosystem that want to produce language bindings for their libraries could use. So we could all like pool resources for, reviewing those types and exposing methods and whatnot. There's a lot of things that fall into that category, and we have I have here in the issues other users of Unify, which might be able to leverage our Bitcoin FFI bindings libraries. So LWK, Liquid Wallet Kit, Rust Noster, Cove, PayJoin Dev Kit, Breeze SDK, the LDK Node project, and of course us BDK. So these are all current users of Unify language bindings, and they must write their own types coming from Rust Bitcoin or other libraries that are sort of like core that everybody uses in Rust, and they must write their own wrapper types around those if needed. And instead of doing that, it'd be great if we could pool our resources and use a single dependency that everybody would be able to then use the types from and run with that. So this is what this project is, and we're hoping to see it grow and release more types in the future as maybe more users come in and leverage it. So that's one thing. Check it out if you are interested in bindings for yourself. And lastly, I wanted to talk about some of our sample applications. There's a few things here. The first one I will talk about is the one that I maintain myself, called the DevKit Wallet. The DevKit Wallet is an Android app that has a lot of the the BDK, the core BDK API. It's a simple wallet. It uses testnet, regtest, testnet 3, testnet 4, signet as well, and it just doesn't do mainnet. And yeah, so that's an example, one of our sample applications we maintain. It currently has a few variants. So there's a Kyoto, there's a 030. So if you're using the old API, that's there. And we have a Kyoto variant, which is the compact block filter client for the BDK uses, and then an Explorer client. So if you want to see BDK in action for an Android app, this is the place to go. I try to maintain this app as a fairly simple, sort of like not a lot of Android bells and whistles. It's focusing on BDK, so it's not a production application. Of course, it has a lot of little quirks, but it does focus on showcasing BDK and how to leverage the API. So that's one of the good parts about it. as opposed to picking, say, an open source app that is using BDK, which is super cool to see in production, but might also have a lot of layers. Big production applications tend to be, of course, complex, and they're hard to get into the code base, and it's difficult sometimes to follow logic across the whole app and layers, whereas little sample applications like this are meant to be simpler for devs to get going, or to fork and just like go there, do their own thing from it. So that's the Android one. We have an iOS one as well. This one is maintained by Matthew Ramsden here, Rees. He maintains this. It's similar. It looks maybe cooler, so that's one thing. But it's the core of it is leveraging the language bindings. It's a simple wallet. Actually, I believe this one is available on TestFlight. So if you are an iOS user, you can probably pull it from TestFlight. I don't know if there's documentation on that. Maybe not. You can reach out on our Discord and ask him how to get it. I don't think it's difficult. So you can even use it on your machine. Same actually for the DevKit wallet. If you want to use the DevKit wallet, you can just take our releases. I have them here. Actually, this is a tag. I should add it as a release, but you can download the APK directly and use it on your phone. So that's a good, cool thing to do if you're interested in using like a testnet reg test, a Signet wallet locally. And lastly, there is one more sample wallet called it's a desktop application called Godzilla Wallet. This one is under my GitHub, but you'll find it's a desktop application that uses BDK JVM. So another one of those sample applications, fairly easy to go through and understand, and this one uses Kyoto as well, the compact block filter. So that's kind of cool, and showcases how to build desktop applications as well. Using, if you're a JVM user, you'll be familiar with that. And that's it. That's what I had for the presentation today, guys. I think we're closing in on the hour, and I hope this was useful. Let us know. We're hoping to post this on YouTube, so hopefully you're watching this on YouTube, and more to come. So thanks everyone, and we'll see you next time. Cheers.